Love to Pete Cheslick, right? Okay, so understand why Docker is such a big deal. My assumption here is that you guys are not completely clued in on Docker yet. And so we need to establish why you should even go thinking about securing Docker before we would even want to actually secure Docker. Geez, what's going on there? Sorry. Consider Docker security concerns. And then finally, ponder a rational Docker adoption strategy. So that's kind of the framework, the frame of the talk. All right. So as an ops director, I am personally guilty of pooping rainbows on security concerns. Brian, where are you? Raise your hand. Brian looked at me one day and said, you can't do that. That's not secure. And I said, oh, you care about security. Great. Help me care. Okay? He worked for me. He'll tell you. Am I making that up? No, I am not. So, all right. So who am I? Well, geez. Sorry, this thing's got a really light touch today. All right. Punt. Who am I? I'm a technologist, all right? I like sharks with freaking laser beams. I am a community builder. I've founded and run Austin DevOps. If you're not coming, please do, okay? If you're here, you're obviously already interested in DevOps. So I am an extroverted nerd. I not only write code, but I talk about it when I do. And I am an evangelist, right? So I work for Stack Engine. I am Stack Engine Jesus. What? All right, you're saved. And come to Docker Austin. Come to Austin DevOps. Go to Cloud Austin. Your participation in these communities is what will take DevOps and make us care about security like Brian made me care. If without your voice there, we're just going to keep shitting our rainbows and you're going to keep shoveling. We need you there to make us better. Please come. What is Stack Engine? Okay, the commercial portion. Stack Engine is all about Docker, Docker, Docker. All right, really what it is, it's an orchestration tool because Docker changes the game from configuration management. I want to mention CF Engine because nobody else has yet, even though Pete mentioned Burgess. Service discovery, and we also have a community, of course, because, well, I'm there. And if you like what you hear, come and join the conversation in our community. You can find some swag and stuff in the back along with my cards, and we'll talk more about it. All right, and of course, buy copious amounts of Stack Engine goodness because my CEO told me to say that. All right, so who are you? Anybody know that guy? Doesn't it look like he's singing that song? All right, so how many of you have heard of Docker? Of course, right? How many of you have experimented with Docker on the job? Much fewer. Anybody actually using Docker in production? Raise them high, please. That is an extraordinary number of people, actually, by percentage. And typically, the number in the size of this group would be about 4. So we had about triple that. That's awesome. All right. So Docker with unicorns? Nothing. Man, Gandalf's worried about Balrogs, okay? And Docker does present some really scary security concerns for the security hobbit. All right. So before we go any farther, you need to understand a bit about how I think because I'm a little different than most people. All right. Yeah, the pun probably makes that really evident. All right. So I don't look at a problem and go, what tool am I going to use today? Nor do I look at the problem and say, what am I going to do about that? The gentleman, Mark Tessaro, who was here just a moment ago, laid out beautifully how I approach a problem. I think about it from a philosophical standpoint. Why am I doing what I'm doing? Only after I have worked out why I'm doing what I'm doing, when I talk to somebody like Brian and say, how are we going to go about accomplishing this? And then once I talk to Brian and we kind of come up with a model for how we're going to go about doing that, then we talk implementation. And only after we talk implementation do we find the tool that is going to match how we want to work. Because what you don't want to be is the guy that says, hey, I have a Java, everything looks like a class. So don't be a tool is the lesson there. All right. This is a interstitial slide of microservices, right? Docker, Docker, Docker means microservices, microservices, microservices. All right? The basic idea is that you have some sort of boundary in which a unit of work is occurring. All right, so that's been around forever. Service-oriented architecture. How many of y'all have have a service-oriented architecture without Docker? Yeah, how many of y'all really have a service-oriented architecture without Docker where you have all the interfaces that you're coding to, all the Martin Fowler hotty-toddy, new cool hotness? Yeah. And what that means is, and why? Well, let's talk about that a little bit. See, this is what Docker does. Docker makes microservices available to mere mortals. So this is me. This is somebody using Docker. All right. Container infrastructure becomes the boundary. And this is where it gets really important because before, I had to reason against this optional interface that I was writing in the code. whether it was in PHP or Java, or if you're using duck type languages like Python or Ruby, you don't even have an interface that you can write. I guess you can get away with some abstract classes and whatnot, but it's very different. All right, so what does Docker do? It creates this infrastructure boundary, and all that does, okay, it's not better or anything like that, but what it does is it makes it easier to reason about. Because I can use a container as a mnemonic for a service, I can say what's happening inside this container is the thing that I want to happen inside only this container. And when I want it to do something else, I have to talk to another container. Usually that's through some sort of RESTful API. Aha. Now I have to think externally. It's required rather than it being optional. Why is this important? Simple. You have real-world work to do. And somebody is standing on your head going, are you done yet? Are you done yet? Are you done yet? It's usually your favorite project manager. And this is important, right? This is the stuff that's moving the business forward. Okay, so are you going to write that interface or are you going to write the feature? If you're using Docker, you have to do both. Well, the interface is already written for you. And what's really cool is Docker's container technology is still super immature. If you go and compare it to the 2002 BSD jail feature set, it still isn't there yet. That's no lie. And it's nowhere as close to zones if you've had the joy of using Solaris at some point in your life. I mean that both figuratively and literally. So what did Docker do to make them so relevant? They figured out how to make it easy for developers to actually work with containers, to actually package their code. It's Docker's packaging tools that are actually making Docker matter. So what happens here? You end up with an extraordinary business advantage. How? Well, today, you have a big ball of code, and you have 50 people working on it. You have 50 factorial lines of communication that could potentially need to happen. You ever put 50 factorial into your calculator and watch it, like go, all right, so tomorrow, what if you had 15 teams of 3 people each? Well, we all know from basic psychological studies that teams of 3 to 5 people are self-organizing. They don't need a project manager. They don't need communication facilitated for them. They can just do that. So what that means is we went from a 50 factorial problem to a 15 factorial communication problem. Suddenly, that project manager can be much more effective because further, we have these infrastructure boundaries. And the only time that this guy over here needs to talk to this gal over here is when there's going to be a breaking change. We have severely limited the need for communication. Now, that might sound antithetical to the whole DevOps culture, woohoo, hug me thing. No. Part of the problem is a lot of the communication going right now is simply waste. And it's an awful lot of friction. I want to do it this way. Do I want to do it that way? You know what? I don't care. You want to write that service in Ruby, you go ahead. Just make sure that you keep the API just the same. I want to go write mine and go because it needs to be faster. All right? Whatever goes on in that container stays in that container. It's kind of like Fight Club, but for technology. All right. So what does this mean? It means that that service, because it's self-contained, can move at its own pace. It doesn't need to wait on the user management system. It doesn't need to wait on that guy getting that thing done over there that he just can't seem to finish because there's just one more complication after another. That service can move at its own pace unless it's making a breaking change. More features? Well, you got to buy into this. Features mean revenue. Okay? If I can sell a hammer online better than my competition, when the customer wants to go and buy lumber, they're going to go to my store. I win. Technology wins no matter what business you're in. So that's why Docker matters. Oh, and then there's this innovation thing that Mark talked about in the last presentation as well. Innovation is the lifeblood to feature development. So here's what you can do with Docker today. I want to upgrade Java. How many of y'all just freaked out when I said that? Right? Especially if you're a developer, because you've got your hand-built, bespoke, artisanal development environment. And so you go and you upgrade Java, and it doesn't work, and you say a lot of filthy things, and then you take 2 days to go and put your development environment back together. You can run your Java, PHP, whatever, runtime in a container, keep your code on your machine with all your favorite tooling, upgrade Java, run your tests, and go, wow, look, it worked. Cool. Or, gosh, it didn't. It didn't. You boot to Docker and you destroy it, boot to Docker up, you're ready to work again. It takes about 5 minutes to try that experiment. Now consider this in terms of your developer behavior. Boy, if I could just upgrade Java, I could save myself 2 weeks of work because of all these new cool hot features that I would have to essentially write myself. All right, there are a whole lot of problems with that statement, right? Now I can actually try it though. and I can run all my tests against it. And what's even better, I can share that with my entire team in moments with a Git push. Okay? Is anybody using Vagrant right now? All right, so this is the same model as Vagrant, right? So you can do this with virtual machines too, because so few of you raised your hands. And if you're a developer, right, if you're moving in that DevOpsy direction, you're not ready to look at Docker yet, go look at what Vagrant can do for you. It will change the way you do work for the better. Quick metric, Brian and I were able to put 8 hours per week per developer back in their week by moving them to Vagrant. 8 hours per week per person, 10 people. That's like hiring 2 FTEs. That's cool stuff. All right, so Docker can provide you with a competitive business advantage, but it's terrifying because you have this new infrastructure piece out there and all these zombies are trying to get at you, right? That's just, All right, so developer freedom is antithetical to practical security. Remember, I'm not a security person, so that seems somewhat unenlightened to me. It also seems somewhat practical to me, right? Because I don't really know a whole lot about security, so I'm sort of afraid of it. Now, you might think to yourself, hey, you picked the wrong picture because isn't that sort of a disaster? And the answer is yeah. Because Docker adoption will cause you a disaster or two, at least. I promise. Here's the story. All right. A lot of people are looking at Docker adoption and going, wow, process density. I'm only using 10% of a machine. Now I can get it to 90%, right? Yeah, you can actually. All right. And what does that mean? Well, I mean, right now we're using 2.2% of all the power, that's coal right there, that we generate in data centers. And that number is supposed to go up to like 7% in the next 10 years. Docker adoptions are cutting infrastructure costs, spends by 50 to 80%. Now, that's not me making a number up. That's me talking to people who have gone through Docker adoptions and measured it. Okay? So in some cases, it's even higher. But density comes with its own problems. So I'll tell you one story about a company that went and cut its Amazon. They set out to cut their AWS bill by 40%. Ended up doing it by 60%. So they were happy. Now, they're very tied to retail. And their marketing team had this really good idea and put out this promotion ahead of Black Friday. Okay? Now, what happened? Well, typically, before Docker, 10% was what the web server was running at. And of course, load would build and build because marketing had a good idea. And then an alarm would go off, but the rate was like this. So they had plenty of time to spin up a new machine and put the, catch up, right? Well, guess what? If you're using 90% of a machine, you know what your runway is? It's about 0. Their site went down. So when you go and solve one problem, you often create another way of having to think. Be wary of this. Don't try and anticipate. Don't not go and adopt Docker because this could happen to you. This will happen to you. Not this particular thing, hopefully. Adopt Docker in a sensible way and learn. Okay? Don't do it. Now, this particular shop, it is in their DNA to be on the ragged leading edge of everything. So for them, culturally, it was cool that this happened. They were just like, great, it happened 2 weeks before Black Friday, so now we know what to expect for Black Friday, and they implemented Mesos in 2 weeks or something like that, which is kind of amazing. All right. Lessons learned from early ops adoption will inform your security efforts. Start now with something that's low risk, some internal app that's been sitting there, and even if you break it, the users of that internal app are just going to be thrilled that you even cared to touch it, right? There's your app. So, I gave you a quick summary of Docker. The first one was significant business advantages. The second was an example of cost savings. That's revenue, that's profit. They did a big interview with me on Linux.com a little while ago. If you want a whole bunch more of that sort of thinking and examples, just go there and read that. Have a good time. I don't want to take up all of our time talking about that. So my answer, Docker is worthy of your consideration, says Docker and their $1 billion valuation. You just can't ignore that. It's kind of crazy. All right. So now let's talk about bad actors. All right, identity management. This is something that really trips people up. They're like, no, it can't be that bad. All right, I'm going to show you that it is. When you have access to the command, Docker run at the command line, you are root. I don't care who you think you are root. Orchestrations tools such as mine, Stack Engine, will allow you to ameliorate this with access control lists and things like that. So there are tools out there that will do this through a GUI, API, and so forth, all right? So that guy, of course, can help you understand all that because, well, he's brilliant and I'm not. So if you're looking to secure something like that, if you're looking to think through how can I test this to make sure that it actually is keeping this problem I'm going to show you, away. A guy like James Wicked is the guy to talk to. So here's the command right here. This will, regardless of who you are, the fact that I can run Docker run lets me do that. And the way it does that is that entry point switch lets me take whatever command was going to run the container and substitute my own command. Now, keeping in mind the Docker daemon is running as root, I have now just removed, because I mounted as a volume. Oh, that broke on a bad place. Sorry about that. That mounted the root users directory as the root users directory in the container. So when I remove the directory in the container, I'm also removing the root user from the host. Yep. So that's either some bad actor or some developer with a good idea. Right? Sometimes it's hard to distinguish between the two. All right? That's a real deal. I actually went and tested that one. All right? Now, I wrote StackHub HA proxy, and all it's supposed to do is just spin up HA proxy and let it find its backends. You know, like you got a million Nginx's, it'll find them for you and keep track of them, right? So you could do this with any Docker image because you never get to the execution part of the HA proxy. It's interrupted at rm root. All right. So Docker came up with this idea called content trust. It's pretty cool. So I hate the curl bash, and I hate the GitHub releases. But this isn't a new problem. We've been doing this over and over again. Indeed, if you don't know what's in your deb, do you know what's in your deb? Who made that deb, right? And just because it has a signature on it, what does that signature actually mean unless you know who the signer is? Isn't that the whole point of an SSL chain of trust, right? You know, the authenticated signer, why do we pay all that money to Komodo? So they came up with content trust. This is a new idea. It just rolled out with Docker 1.8. Now, what does it do? Basically, it allows a user to say, hey, I'm going to sign this thing and I'm going to publish it to the Docker Hub. And it allows you in your Docker daemon to say, I will only take trusted content, something that is signed. I won't take anything else. But it comes with some caveats, provisos, and whatnot. If any of you have kids, that's my favorite kid show ever. So, rule number 1, I can't bring anybody back from the dead. So make sure you RTFM, okay? Because let's face it, it's really easy to misinterpret what people tell you is happening. Make sure you know what's happening yourself. So, because there was a lot of you who are not completely into the Docker thing yet, let me take a brief moment to explain, just from an infrastructure perspective, what's going on. Today, in the cloud, you have a host OS, you run some sort of hypervisor, and then you run a guest OS on top of that. Well, from a security perspective, that sort of freaks me out, because don't I have to secure this and this? And this one isn't necessary. This is some Linux, and this is some Windows. I have a big pile of problems on my hands already. Oh, and then there's this thing, too. Venom, anyone? We'll talk about that in a minute. All right, and then, of course, I have all my bins and libs, and then the actual application. Okay, what does Docker do? It just rips out a whole pile of that stuff. There is no guest OS. All Docker does is it takes a piece of the kernel on the actual base machine, and it says, here you go. There are actually commands in Docker where you can say, I get this much CPU, I get this much memory, I get this much I/O, and so forth and so on, because LXC is under the covers. So there is room in here, you guys, if you want to come in. I'm sorry that you have to stand out there right now, but please come on in. There's plenty of room in the, the grassy area. So that's one of the big advantages. This is where you get the density, right? I don't have all of this weight of the OS and all of the risk of this OS sitting right there. All right. So Docker as a hypervisor. I have not yet been able to figure this out. Look at y'all waiting. I have not yet been able to figure this out. People, it has become part of the Docker canon, the Docker Kool-Aid. You should run Docker in a hypervisor because it's more secure. People say that, and I'm like, well, let's go back for a minute. If I run Docker here, and my application is there, how is that any more secure than running Docker here? What is it about this physical machine versus this virtual machine that makes them any more secure? That one still has all the same network privileges for the application to work. It still has all the same firewall rules and everything, right? There is no difference between this and this. So what is this hypervisor buying me? Well, it's a really simple thing. It's only a few lines of code, and it's battle-hardened, right? It doesn't break. Yeah, and then there was Venom. Remember, first there was Heartbleed, then there was Shell Shock, and then there was Venom. Yay! All right, so what was Venom? Venom was just a way to crack into, just to get into one VM, get outside into the hypervisor, get into a second VM on that host, and then attack the application from the inside, spread yourself to another host. It was a very big deal in the cloud. So I decided I'm going to take a look at Docker as a hypervisor versus KVM and Zen, the two most popular open source ones. And so first off the bat, Docker just loses. Docker was born in 2013. It's only 2 years old. It can't be battle hardened yet. We have to accept that. But in the context of the possible business advantages of Docker, I'm willing to take that risk in certain cases. So Zen 2003, that is stayed, right? And KVM 2005. These are looking really good. All right, let's dig a little deeper. Lines of code. Docker is 300,000 lines of code. The typical developer can keep about 50,000 in his or her head. So that seems grokkable, right? Okay. Zen is 500,000 lines of code. Same thing. KVM, world's most popular hypervisor, 13.5 million lines of code. As a security person, does that freak you out? You know, as just a general paranoid ops guy, that kind of freaks me out, right? You know, you know, small tools, do one thing right, do it well. So yeah, that kind of bugs me. All right, so then there's code churn. Does this thing work? Yeah, all right. So first of all, go by the Black Duck booth and say thank you to them, because you can go to OpenHub and you can get all kinds of really cool statistics about any open source project. So that's where I got these. So you can see right here, you know, this thing is just not my friend today. All right, whatever. So at the top, you can see that in about July of 2015, there's this huge jump in the size of the Docker code base. What was that? Well, the next one down, that orange line is C. That entire jump was a whole new language added to the code base. That trips me out completely, right? But it's also expected in a new project. We think, I couldn't get anybody from Docker to answer me. We think that is libc, I'm sorry, libnetwork going in. When they acquired Socketplane to do their networking, that was probably going to be written in C. So we're thinking that's them integrating libnetwork. We're not sure. But it's a big jump. It's an awful lot of code to the code base, and it was in like 2 months. That was fast. All right, so that looks really suspicious. And then I started looking at Zen. And I get this sawtooth pattern. Now keep in mind that, you know, this relative period of about every 2 years, code goes up, and then they pull out a bunch of cruft. Code goes up, they pull out a bunch of cruft. Just because you're seeing that up there, there's still plenty of churn going on down here too. So yes, that is sudden, but that's a new project. This is an old project, and it's still doing that. And then I looked at KVM. They don't throw away anything. I mean, that's almost perfectly, you got one inflection point right here. It's like, oh, let's go faster. How much bit rot is in there, for crying out loud, right? I mean, who knows? Okay, so now, the next question. How fast is it actually moving? Well, Docker moves at roughly 600 commits per month. Over the last 12 months, that's been their average. All right, new project, that's a lot, but Zen moves at about 200. That makes me feel a lot better. That's something that I can imagine processes being built around that would actually tell me what's going on. And then there's KVM at nearly 6,000 commits per month. That's a lot of change. And if you have to keep up with all of that, somebody's got to be making sure that things are right. Or they've got to have intensely mature processes to make sure this is working. And KVM is the thing behind most OpenStack deployments, and allegedly Amazon, and so forth. So now I looked at contributors. Well, Docker has, you know, they claim 600, so there you go. And Zen has about 100. And KVM has, in the last year, nearly 4,000 people have touched that code in a way that they were able to submit a commit. Is it likely that one of those people had some bad intention? I think so. I have bad intentions. So this is a summary of it. All right, so Docker really loses on what I think is the key metric. It's battle hardenedness, right? But I'm willing to accept that to gain a possible business advantage in certain circumstances. Zen gets a little weird with the, oh, I'm sorry, I messed that up. That's wrong, ignore that. Yeah, and KVM loses everywhere else. So, you know, when you hear Docker hypervisor, you should run Docker in the hypervisor, it keeps it secure. I really encourage you to consider that a little more carefully. If you can run Docker on bare metal, you're going to have a significant savings in your usage. All right, if nothing else, running Docker in a hypervisor as a security measure should be considered more closely. And again, thank you to the OpenNet people, or I'm sorry, OpenHub.net people of Black Duck. All right, so what does this all mean? Well, here's the opportunity that I really see. And I'm also essentially going to be parroting what Mark said in his in the last talk. Back in 2009, ops was a bottleneck. We sucked. We were an impediment to the business, and we needed to be outsourced. And I own that. Today, there's DevOps, and things have changed and are changing. To say that it's all magical and unicorny now is wrong. We're moving in that direction. Okay? And we have a clear path ahead of us now. We understand what we're doing. We understand how we're going to do it. And now it's a matter of just taking the time to make the steps and bring people along with us. All right. Where is security? Well, today, security is a bottleneck. It's off in its own silo. Nobody cares about it. And Pete referred to that security asshole, right? I was the ops asshole. No, you may not touch my server. So I can understand that. It was a safety thing. I'm gripping. I can't let go of that because if I do, it's my ass if something goes wrong. So how many of you have read the Phoenix Project? How many of you have not read the Phoenix Project? Keep your hands up. You have not read the Phoenix Project. Somebody wrote a book about your life. Read the damn book. All right? For the rest of you who didn't get one, I'm not going to throw books at geeks all the way back there. That's just asking for a lawsuit. Look, if you haven't read the Phoenix Project, go and read the Phoenix Project. You can get it for $2 on Audible and listen to it. You can get it for about $15 on Amazon. If I wasted your money, pick up one of my cards. Call me. I will buy you lunch and refund your money. Now, I have said this to well over 5,000 people in my lifetime now. I have bought 3 lunches. 2 of them were because people were like, oh, I just wanted to talk to you about the book. One of them was a guy who couldn't find employment. So I'm pretty confident that I won't be shelling out too many bucks, and having lunch with one of y'all wouldn't really suck anyway. All right, today's security is the bottleneck. It's off in its own little world, and that's the thing that needs to be changed. And I see black box testing as a way to deal with this. But with full cheats on, game mode, right? So yeah, I can look at this Docker container and start poking it from the outside and doing all the outside things to it, but I have access to the code. So that's going to inform how I poke it, right? So while I want my testing to look at it as a black box, I can cheat, look inside, and get some intuition about how I want to do that. Now, why? Well, here's the thing, folks. Security is just another form of quality. So is performance, right? So let's stop trying to reinvent the wheel. Yeah, we're security. We do it this way. Let's instead take all of the awesome thinking around quality, test-driven development, continuous delivery pipelines, continuous integration pipelines, and apply that thinking to security because, well, why not? Okay, so what this does is it means that security can then move as far to the front of the SDLC as possible. And this is one of the key things of Lean. And since DevOps is coming out of the Lean movement, this makes a lot of sense. If you have read, so a lot of you raised your hand when you said, how many of you have read The Goal by Eliyahu Goldratt? Okay, now, the Phoenix Project is a blatant ripoff of The Goal. By the way, the Phoenix Project is a novel for those of you who haven't read it. It's not a technical book. It's just a story. And I'm going to say sorry that I kept you up all night because you couldn't put the book down right now. The Goal is equally interesting, but it's about manufacturing. It's from days when you used to smoke cigarettes in your office and call the women honey. So, be ready for that. Kind of a bit bracing for me as I listen to it as an audiobook. But the point of the matter is, this is, again, stuff that's been happening for 30 years. It's the theory of constraints. Why reinvent the wheel? So what did they learn? Well, they had this one machine that was the bottleneck on the manufacturing plant. And common sense. Hey, instead of taking materials and running it through that machine and then hoping they're good on the other side, why don't we make sure that the parts that we're having machined pass a quality check before? Because if they don't pass a quality check here, why waste this machine's time? Because this machine dictates the cadence of the rest of the manufacturing floor. Well, guess what? Does that sound a bit like security? So what if we could move security to the head of the line? What if we could move it to the front of the SDLC and make sure that at least some sensible set of security checks were there? Docker enables this. Just like microservices, it doesn't make it possible. It's always been possible to do it. It simply makes it easier because now you have this discrete piece of infrastructure to test. And that is much more grokkable than 13,500,000 lines of code, right? So again, Docker doesn't make it possible. Docker simply makes it possible for mere mortals. So, and finally, attack yourself. Make it a game and build it into your daily workflows. Let's go back to these microservices and micro teams for a minute. I have team A working on the user service, and I have team B working on a class service, school classes. All right, great. And they have an interface that they have to agree on and so forth. But, I don't know, once a week, team A stops what they're doing and they attack that. Anything that they find, they don't go, you suck. No, they throw a party. Hey, man, we found these problems. Let's fix them before somebody else finds them, right? The blameless culture. Let's celebrate those things. Let's find it. And finally, let's code it up. I'm talking about Netflix Chaos Monkey here. The Simian Army is the entire thing, right? Attack yourself. Find a way to write security things that are going to go and attack something and report back what the errors are. And when you find something, when you take your entire website down, don't go, shit. Go, yeah. Because you found it before somebody else did. And that means because you knew you were looking, you can get it done faster and there was no other harm done. Okay? Learn to attack yourself. Learn to make that part of your daily workflow. And make sure that you build a culture around celebrating when you find problems rather than going, let's just make sure nobody sees that until we can get it fixed. Because you know what? If nobody sees it, it's not going to get fixed. We have a real problem with getting the business to prioritize ops work and security work. Built a culture around we get rewarded for being firefighters, and when nothing's going wrong, we get laid off. Does that sound like it needs to change? Guess what, folks? You own that. And again, how does this come back to Docker? It's simple. Docker makes this more possible because it makes things more easy. Yes, I said that. Security is a form of quality. There is no need to invent the wheel. Reinvent the wheel. There was a need to invent the wheel, but it only needed to happen once. All right. Finally, this is sort of what do I want? Sort of tangential. At the CD Summit last week, Jez Humble came to speak. Jez Humble is the guy who authored the book Continuous Delivery with David Farley. So he is the seminal founder of the idea of continuous delivery. And he wrote a book called The Lean Enterprise. If any of you are managers, he recently released that book while he was at Chef. It's a fantastic book. It's a really great look at how large organizations can move in much more agile and lean fashions. It's really well done, and it's based on his experience as a consultant going to many large organizations, including, if you've ever heard of it, HP applying agile and DevOps processes to their firmware successfully. Firmware. If you can move firmware into a continuous delivery pipeline, for all of you who are thinking, I need a continuous delivery or whatever. Yeah, well, guess what? They did it with firmware. Take a deep breath, start thinking a different way. Well, he talked about this thing called the strangler pattern. So I thought this was really interesting because I got this big pile of legacy code I have to deal with. What am I going to do? Well, I know what I'm going to do. I'm going to rewrite it from the ground up because that's easy to sell to the business. And there's no risk in that, right? Yeah, me and 5 other guys, we're just going to go over here and we're going to rewrite this system that's been around for 20 years that's on CD Datacom and COBOL. Yeah, that's going to work, right? No. What I'm going to do is I'm going to take one of the services, low-hanging fruit, that thing provides. I'm going to split it off and I'm going to write it in a Docker container. And then when something else needs to be upgraded, I'm going to peel that off and I'm going to figure out how to get it to talk to that. And I'm going to write it in a Docker container. And eventually what's going to happen is I'm going to end up with this. Now what is this? This is called a strangler fig. And because in the rainforest near Angkor Wat, there is a competition for sunlight, the strangler fig starts out in the top of the canopy and grows down around a tree, eventually strangling that tree and coming to life itself. So this is CD Datacom, and these are our microservices. It has to happen over time. Taking a big boom doesn't work. So I have a saying for this. Think evolution, not revolution. Revolutions are bloody, and they never have the outcome that they started with. Bolshevik revolution, yada, yada, yada. All right, the great leap forward. Probably not. So think about how to evolve, not revolve. So the question was, is there anything else that you can do to control access to the Docker pipeline? So the first thing that I would tell you is, like any sort of execution, make sure that the thing that's executing your code is some automated process, not a human. And then humans, except for 2 or 3 trusted ones, cannot get in and execute arbitrary code, right? So that's kind of that's kind of a basic statement. So one mnemonic that Brian and I had, we didn't ever do this, but I really wanted to. You know the old manufacturing thing where you had days since last accident, right? And it would be like 62, and then somebody would fall and break your leg, and they'd erase it, and you'd go back to 0, right? I always wanted to put up on our whiteboard days since last production login, with the same thing, right? So and as a fun metric for, so that's how I would kind of go about approaching that from the beginning. Make sense? All right. All of this big pile of spaghetti that you're already running behind your firewall, keep all of those services behind that firewall too. Those should not be public. They should be in a VPC somewhere, what have you. And SSL, and TLS. That way a bad actor on your network can't look at what's going on between 2 services and start stealing information like credit card numbers, right? How did those 70,000 or 70 million cards leave Target? I don't know that they know yet. I know this. If I wanted to steal something, that's how I would do it, is 1 card at a time with some little process that nobody's seen. So if I can secure the communication between them with TLS, now as long as I don't have access to that secret, I don't have access to the information. So that's a start. Again, Docker is not awesome with insecurity. That's one of their biggest problems. They know it, and they're working on it. With 1.9, new things are coming. So again, keep that in mind. Don't run the crown jewels of your organization in Docker tomorrow. Don't go strangling the crown jewels of your organization with Docker tomorrow. Find something that needs strangling and strangle it first. Get wise. Answer these questions with your experience, your company's requirements, because you might be HIPAA, and I might be FERPA, or I might just have a bunch of data that I've collected from Twitter that I'm aggregating, so it's all public data, and I don't care anyway, right? So we each have our own context we have to answer these questions in as well. I appreciate y'all taking the time to come and listen. Thank you.